A regular pentagon is centered about the origin and has a vertex of 0, 4. All right, it says, which transformation maps the pentagon onto itself? So like the last problem, we're trying to figure out how we can either translate, rotate, reflect, or dilate, because those are our transformations. We're trying to figure out how we can do one of those to get it to line back up perfectly so that all of the sides are in the exact same spot. So if we reflect across the line M, we would take this top triangle here and we would reflect it down here. That's kind of a rough sketch, but I hope you can see that all the sides are not going to line up. So that's not going to work. So I'm going to go ahead and cross that one out. If we reflect across the x-axis, okay, so now this is our line of reflection. So again, all of this stuff up top would end up reflected down bottom. And I hope that you can still see that there's no way that that's going to match up. It's going to be something like that. So again, those lines are not going to line up. And for it to map onto itself, it has to line up perfectly. So then a clockwise rotation of 100 degrees about the origin or a clockwise rotation of 144 degrees about the origin. So something we learned super early in the year is that regular polygons do have rotational symmetry. And to figure out their rotational symmetry, you take an entire rotation, which is 360 degrees, and you divide it by however many sides they have. In this case, it's a pentagon, so it has 5 sides. So this shape has rotational symmetry every 72 degrees. So if you rotate it 72 degrees, it would map back onto itself. If you rotated it 72 degrees again, it would map back onto itself, and so on and so on. You can keep rotating this every 72 degrees, and it'll map back onto itself. So you could rotate it 72, and then if we add 72 to that, that would be 144. If we add 72 to that, it would be 216, 288, and 360. So these are all of the rotations that you can make for this pentagon to map back onto itself. So 144 is one of those, so that would work.